Good morning, everybody. Oh, that's not good, Isaias. That's never good. Hopefully, it looks up for you. It's only Tuesday, so you're gonna have a long week ahead of you. All right, yeah. So as I had typed in the board there, I can't believe that next week is Thanksgiving already. This year is just flying by. So with that being said, I just want to kind of go over the plans. Um, for this week and next. So today we're going to go ahead and continue moving forward with Unit 4. We're going to look at 4.02. Then in Thursday's class, we'll take a look at 4.03. And then next week, Tuesday, we'll take a look at 4.04. We will not have a class next week, Thursday, because it's Thanksgiving, so you have off of school. Yay! So we get a short break, and then once we come back, we have a couple weeks before winter break. And then once we come back from winter break, we're preparing for final exams. So things are going to actually wrap up pretty quickly from here till the end of the semester. Things are going to go really fast. Oh, that's a rough one, Isaias. I haven't had that scenario happen to me, but I've had my fair share of car troubles and windows shattering while driving. So I definitely feel the pain there. I'm glad that you are okay though, and it didn't cause any harm to any individual. So look on the bright side. You're okay, and so is everybody else. Cars can be replaced. There is a silver lining everywhere, you bet. And that's a big one. All right. Any questions with 4.01? So, as I was looking at the assignments coming in, things look really good. I didn't see any areas of concern. One thing we just got to make sure moving forward that we're in the right mode. So as we start moving forward with our trig, we're going to be switching back and forth between radian and degrees. So making sure we're in the correct mode in the calculator is going to be a big one. Okay, then today, so we talked about radian and degrees, switching back and forth. We talked about DMS last week, and that was about it. Arc length too, we talked about. So today we're actually moving on to our trig. So we got to introduce trig, and then in Thursday we're going to look at the unit circle. The unit circle, I kid you not, will be your best friend. So if you have the capability to print off the unit circle, I will email it after class today so you kind of have it as a head start. It should also be in the modules area, I want to say. If it's not, I'll make sure it gets in there. So it might not be now that I think about it. So I'll definitely make sure that it gets in there for you guys to look at that anytime you need it. So it'll be a quick, easy thing to find. But that's going to be your best friend from now until I'd say probably the end of the semester. We're going to be looking back at that at every homework assignment. We're going to need it for our tests. We can add things to it. So it's just a circle with a bunch of numbers and values on it right now, but we can make it very useful for us moving forward. So that'll be something that you'll want to print off, and we can take care of that after class today, before Thursday. So just a heads up with that. This should be review for you. You should know your 6 trig functions already, but it has been a while since you've seen them. So the 3 main ones are your sine, cosine, and tangent. And you've probably heard of that acronym SOHCAHTOA before, but I'm going to throw it up on the board as a reminder. All right, so there's that SOHCAHTOA. It's just a quick acronym to help you with the setup of the three main trig functions. So sine, when you're looking at a specific angle, and that specific angle is going to be our theta, that will be labeled in the picture for us. We would set up sine by looking at the opposite side and the hypotenuse. So OH stands for opposite over hypotenuse. Remember, hypotenuse is always the longest side of the triangle there, and it's opposite the 90-degree angle that you have. The reciprocal function of that, and this is not to be confused with the inverse function, so you don't actually have a cosecant button on the calculator. You have to use 1 over sine to get that. But the reciprocal function for sine is cosecant, and that would be your hypotenuse over opposite. Cosine is your adjacent over hypotenuse, and secant, which is the reciprocal function of cosine, is hypotenuse over adjacent. And there's abbreviations for these. I'm going to put the abbreviations right below them. So sine is SIN, cosecant is CSC, cosine is COS, and secant is SEC. There you go. Tangent, so TAN, is opposite over adjacent, and cotangent is adjacent over opposite. Okay, any questions with those six trig functions, 3 of them being the main ones that we've already worked with before. And we've seen the reciprocal ones in the past too. That's not anything new to us. Okay, then let's go ahead and actually put them to use. So one of the things today is finding the 6 trig functions. So if they set up a triangle for you, can you find the 6 trig functions using the angle specified? So I'm going to go ahead and kind of partition the board here, and because this is a review topic, I'm going to have you guys help me out to speed up the process. So there are the 3 main ones. Let's go ahead and create the fractions for those using the picture, and then we'll go ahead and find the reciprocal functions of them as well. So when you have a fraction for one of the values, go ahead and throw it on the board. And once I'm done typing here, if we need a refresher with how to do this. So we're looking at the 45-degree angle here. So it says find the values of all 6 trig functions for an angle of 45 degrees. So they give you that angle of 45. They give you the side lengths as well, which was really nice of them. So now we just got to set up those fractions. So sine is opposite over hypotenuse, so 1 over the square root of 2. And I like how we have the 1 over the square root of 2 as our starter. That really helps with the reciprocal function, because we want to flip that. So that's going to be the square root of 2 over 1. Well, the square root of 2 over 1 is just the square root of 2. However, when I go back to the sine function here, I do not want to leave a radical in the denominator of my fraction. How can I rationalize this so that I do not have a square root in the bottom of my fraction? Anybody remember what we would do? Yeah, you're going to multiply by that square root of 2. Good. So we do have to rationalize the denominator if you have a square root there. So you have to multiply basically by that square root value. And that would be square root 2 over 2 then. So that's what that would simplify to. But like I had said, I always like to begin with the 1 over square root of 2, because that does save me a little bit of time with finding that reciprocal function. Okay. What about the cosine value? What's the cosine value of 45 going to be? Yeah, the same thing, right? Because we'll notice that the setup is going to be 1 over square root of 2 again. So we in our heads, we can rationalize that to square root 2 over 2. That means the secant function is going to be what? Yeah, just the square root of 2. It's going to be the same as that cosecant function. Good. So I'm going to box up those. We are 2/3 of the way there. Now we just have to figure out tangent. All right, so what is tangent going to be? TOA. 1, yeah, 1 over 1. Good. And that means cotangent is going to be what? Yeah, the same thing. Fantastic. Any questions with how we got those 6 values? So not a bad way to start off with our trig, right? Definitely manageable there. All right, let's take a look at the 30, 60, 90 triangle. It says find the values of all 6 trigonomic functions for an angle of 30 degrees. So I'm going to highlight the 30 degrees to kind of draw our attention to that. I'll put the 6 trig functions on the board. When you have a fraction for those, go ahead and throw it up there. Good. It looks like we agree with the first one of 1/2, which means hopefully we get 2 over 1 for that second one, which is cosecant. So those look good. All right. Square root 3 over 2. So with the secant, be careful. You're going to have to rationalize that denominator, it looks like. Same thing with tangent. So tangent is 1 over square root 3. Let's rationalize that as well. But before we do that, maybe we should figure out the cotangent. Okay, good. All right, good rationalizing. Yep, square root 3 over 3. So 2 left, secant and cotangent. Yep, so cotangent would then be your square root 3, because that would be square root 3 over 1. There we go. And 2 square root 3 over 3, because for the secant, you have to take the reciprocal, which is 2 over square root 3. So you have to multiply by the square root 3 to get your value here. Perfect. Any questions with this one? Okay, so the beginning ones here are pretty straightforward because they give you the values in the triangle. Can you still do it if they don't give you a triangle? So here they say, let theta be an acute angle and such that sine of theta equals 5 over 6. Find the other 5 trig functions for theta. Well, one of them should be pretty easy to find right off the bat. Which one is going to be easy to find right off the bat? So you have sine. Obviously sine, but what's the other one? Cosecant. Yep. Because that's just the reciprocal. All right, the rest we kind of hit a wall with because we don't have any other values. So if you run into a problem like this, you have to draw a picture. Okay, you guys know me. I'm really good or really like my visual side of things. I'm a very visual learner. So I'm going to set up my triangle so I can see exactly what is happening. If I just pick one of the acute angles in that right triangle, and I'm just going to pick the bottom one, I can then label two of the sides, opposite and hypotenuse. So because that makes up sine, right? So opposite that would be 5, hypotenuse is 6. What can I do to find this other side length then? Yeah, the Pythagorean theorem. So this is a good old flashback to the Pythagorean theorem days. It never really truly leaves us, does it? So let's go ahead and see what we're going to get there for that missing side. So I'm just going to call it an x for now. X squared plus 5 squared equals 6 squared. And yes, you may have some square root values here for those side lengths, and that's okay. What's 36 minus 25? My 11, right? Thank you. So here that's going to be the square root of 11. Because we are doing a square root of both sides, it only makes sense to take the positive value of that because you are dealing with the side length here. So we're going to use the positive square root of 11 versus the negative square root of 11. But now we've got that missing third side length, we can find the other 4 trig functions. So let's start with cosine, and then we will do tangent. So if you want to write on the board, if you have that while I'm finished writing these out, go for it. Good. Square root of 11 over 6 looks good. 5 over square root 11, we just need to rationalize that, so I'm going to put a little equal sign. But I like how we have that set up because it's going to help with that reciprocal function, square root of 11 over 5. And I'm going to just, as we type this, make sure we put parentheses around that 11. So that way we know we're doing the square root of just 11. And then we are actually dividing that answer by 5. And we're not doing the square root of 11 fifths. So we just want to make sure we put parentheses around the 11. Good. That rationalization there looks good. Looks like we already rationalized the next one as well, or the secant one I should say. So that looks good. I am going to go ahead and just retype that cotangent since when I put the parentheses in there, it kind of took over the problem. So I'll just rewrite that real fast. Good. Questions with that at all? All right, so when in doubt or when you're missing information, draw a triangle to help you out. In fact, that's going to kind of be the guideline and the rule of thumb from here on out is to draw a triangle when in doubt. All right. There are a couple things that I just want you to be aware of, some common errors that happen when you're working with your trig functions. First of all, I already mentioned it today, but make sure you're in the correct mode. Most of the time we're going to be working with radians, but there will be times when we have degrees, especially if the angle that we're working with is in degrees. And be keeping an eye on that mode will make more sense when we get to the story problems coming up in a few moments here. So the mode is really going to matter in the story problems that we'll see coming up. The other thing I already mentioned, and I'll point out again, is that your reciprocal functions are not the little inverse keys. So when you see sine, cosine, and tangent on the calculator there, right above them in blue, you see like sine to the -1, cosine to the -1, tangent to the -1. Those are not the reciprocal keys, right? Those are the inverse keys. We will get to inverses later on, but though we do not want to use those to find the reciprocal functions. Instead, you have to actually use 1 over sine, 1 over cosine, or 1 over tangent. You have to physically type that in. And the other thing is making sure you close your parentheses out. So it likes, if you're doing square roots or something, it likes to throw the parentheses in there to start it. Make sure you close it. So when we had that square root of 11, we want to close it after 11. And if we don't close it, it's going to do the square root of 11/5 instead of just 11. So making sure we close parentheses where needed. We don't really have to worry about number 3 too much. But if you were to type something in yourself, you might use some shorthand that the calculator doesn't recognize, but we don't really have to worry about that one too much. It's 1, 2, and 4 that we really got to keep an eye on. But if we're doing our good mathematical practices and we are paying attention to details, these really shouldn't be too much of an issue for us. Okay, now let's talk about how we can use these trig functions to actually solve for missing pieces in a triangle. So we can use sine, cosine, and tangent to help us solve for missing side lengths and even missing angle measurements if needed. So let's go ahead and actually find all 6 parts of the triangle. So we need 3 angles and 3 side lengths. We've got 2 angles already, so let's start there. If I've got 2 angles already, I can find the third. How can I find the third angle in this triangle? Subtract from 180. Yep. So let's go ahead and actually do that. What is 180 minus 90 minus 37? Or 90 minus 37 to speed that up. A 53. Okay, hopefully we're all comfortable with that. That should be kind of the first thing we look for, is can we find the missing third angle up there? All right, from there, we have to find the other 2 missing side lengths. Let's start with side length A. So I'm looking at the 37. Technically, you could look at the 53 if you wanted to, but let's look at the 37. Which trig function should I use to set up a problem so I can solve for A? Should I use sine, cosine, or tangent? Sine, right? Sine would make sense. So if I set this up, I can say, well, sine of 37 degrees equals, now I've got to set up the fraction for sine. Well, that would be A, opposite, over 8 hypotenuse. So we use the sine value of the angle for 37 to get the fraction of A over 8. Now, how would I get A by itself in this problem? Because we want to solve for it. We would need to multiply by 8 on both sides. So I'm going to rearrange things. Multiply by 8 there. And here is where things come important now. So now we have to check the mode, because in order to figure out what A is going to equal, we need to be in degree mode. Notice how it's 37 degrees. So real quick, let's go ahead and hit the mode button on the calculator and switch over from radian to degree. So I got to use my arrow buttons to go down. Hit enter. Right now it's not in degrees. You have to hit enter so that it's actually black and flashing on your screen. And then you can hit the quit. So second quit once it's in degree mode. Okay. And now go ahead and type it in. 8 sine of 37. So when you type that in, you should get an answer there. Does it match up with what you see on my screen there? See? Awesome. You can do this on the school calculator as well, so if you don't have a graphing one, you should be able to select the degree mode. It's an extra little box, usually in the upper left-hand corner somewhere, that you just have to click on to put it in degrees versus radians. Good. Let's do the same idea to solve for side length B. So this time, let's still use the 37 degrees because that's what they gave us to start off with. What can I use to solve for B if I'm going to use the 37 degrees? This time we have to use cosine. So cosine of 37 degrees equals, what would be the fraction we can create from that? B over 8. Good. And just like the last one, we're going to multiply by 8. So I'm just going to rearrange the problem a bit here. And then type that into the calculator to get your value for B. We're already in degree mode, so we don't have to check the mode this time. 6.389. Okay, 6.389, 6.3891. Doesn't matter to me whether you round it to the thousandths or the 10,000ths. 3 places after the decimal point is fine. All right, questions with how we got the 3 missing values. So now we have 3 side lengths and 3 angle measurements. All right, here's a story problem for you. It says, from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, the angle of elevation to the top of the building is 65 degrees. They do give us a picture this time around, so that's really nice. Sometimes they do not give us a picture. When they do not give us a picture, we have to draw one ourselves and put the measurements in. Remember, angle of elevation is from your line of sight looking up. So if they're technically having like a person down here who would be looking forward, normally that's their line of sight. So angle of elevation is when they look up then to get that 65 degrees. Don't forget your angle of elevation there, that term. We have to find the height of the building. So we can use our trig to complete this task. Which trig function would we actually use to find the height of the building? Tangent this time around. So we're going to do tangent of 65 degrees. And what's the fraction we can create for that? H over 340. Okay. We want to solve for h, so we're going to multiply both sides by 340. And what do we get when we do that? Okay, 729.132. I think the decimal just got put in the wrong place there for Rebecca's. What is the measurement here? Feet. Oh, there you go. That would make a difference too. So I'm just going to put units of measure behind it. We are looking at feet, it looks like. Okay, questions with that. So not overly complicated. All right, it says find all 6 trig functions of angle theta. So how would we go about finding the 6 trig functions here? You walk me through that while I'm putting space on the board for the 6 trig functions. All right, use the Pythagorean theorem to find the hypotenuse. Good. Work on that. Let me know what you get for the hypotenuse while I finish writing on the board. Let's use the square root of 170. We'll keep it exact as we set this up. Okay, so we're going to keep that as the square root of 170. All right, we could try to reduce that. I'm not sure if we can simplify it, if there's any perfect squares that go into 170. We can spend a little bit of time looking. So like 4 doesn't work. 9 is out. 16 is out. 25 is out. I think we're going to hit a dead end. 36 is out. Yep, I think we hit a dead end. I'm all the way up to 49 already and didn't work out. So I don't think we can actually simplify the square root of 170. So we'll leave it like that. Let's start finding the fractions then that represent our 6 trig functions. So when you have one, go ahead and put it on the board. Good. I was waiting for someone to snatch up the tangent and cotangent because those are the easiest ones in the diagram because it's the opposite and adjacent sides. The rest you have to maybe rationalize a little bit there. Let's see. Sine would be opposite over hypotenuse, so 7 over the square root of 170. We rationalized that already to get 7 square root 170 over 170. So that looks good. Cosine we have to rationalize some as well. So that's 11 over the square root of 170. We can rationalize that to 11 square root 170 over 170. There we go. Thank you. And then we do the square root of 170 over 7 for cosecant. And let's throw in... Let's put the parentheses around just the 170, so like we did up here. Yeah, so let's not put it around the entire square root because that's technically not how it would appear in our calculator either. We'll put it just around the numerical value of 170. But I like that you got the parentheses at least in there, so that's a start. But yeah, so square root 170 over 11 for secant. Good. Questions with this one? So we're definitely getting the hang of rationalizing those denominators, which is good. I think that's kind of the more complicated piece with this stuff. All right, let's take a look at the next one. Assume that theta is an acute angle in a right triangle. Evaluate the remaining trig functions. We're given cotangent of theta equals 11 over 3. There is one function you can probably find right off the bat without needing a picture. What's the one function you can find without needing an actual picture? Tangent, yep. So tangent is going to be what? 3 over 11. Good. And seeing the tangent might actually help us a little bit better with labeling our sides. So which side is going to be 3 and which side is going to be 11? If you want to use your pointer tools, let's start with the side for 3. Which side is going to be my 3 in the picture? Thank you. And that means my 11 is going to go where? Good. Now, use your Pythagorean theorem. What are we going to get for the hypotenuse? I already know there's going to be a square root in it. 130. All right, we got 2 of the functions already identified, so there's just 4 that are missing. Let's take some time right now and find those 4. So in the space provided, go ahead and write those fractions. All right, we're getting 3 square root 130 over 30. Looks good. Square root 130 over 3 then. 11. Good, we rationalize that to the bottom one. All right, good. Looks good. All right, find the acute angle. This time it says give theta in both degrees and radians. You should do these problems without a calculator. So that just means we have to use the information from lesson 4.01 with switching between the two. So using that pi over 180 or vice versa. All right, so for this one, it looks like we have to figure out maybe, I'm just trying to figure out if it's looking for like the degree measure that is. I think it is. All right, so let's set up a triangle. That's probably where we should start. I have a feeling that this is going to relate to our special triangles like the 45, 45, 90 or the 30, 60, 90. I have a feeling that's what it's going to relate to. Right, it's only, so that's a great question. Rebecca asked, does this only work for right triangles? And the answer is yes, it does. It only works for right triangles. So if we don't have a right triangle, we've got to create one somehow. And we'll start looking at some examples of that later on. So we'll get to some of those more complicated like story problems, as we continue forward. But yes, that only works for right triangles. Yep. So looking at this, it looks like we can have the opposite side being square root of 3, and the hypotenuse would be 2. What is the missing side down here? I'm not sure it's actually needed, but what would be that missing side length? The adjacent, yeah, what's the measurement of it? So using the Pythagorean theorem, can we figure that out? Right? You got there right when I did. Yep, the square root of 1, which is 1. Good. So when I wrote the Pythagorean theorem out on the side there so we could see that. Not sure if that's necessarily going to be needed in the problem, but it can help us identify what type of triangle we're looking at. Is this a 45, 45, 90 or a 30, 60, 90? So looking at the measurements there, does it fit the classification of a 45, 45, 90 or 30, 60, 90? So going back to our geometry days a little bit, seeing if we can remember that. Right? Whoa. Error does not compute. The 45, 45, 90 is an isosceles triangle, right? Because you have two angles that are the same. So if a 45, 45, 90 is an isosceles triangle, the legs have to be the same measurement. Are the legs the same measurement in this picture? No. Okay, so this is not an isosceles triangle. It is not a 45, 45, 90. So that means it has to be a 30, 60, 90. All right, so if this is a 30, 60, 90, I got the 90, but which angle is 30 and which angle is 60? Take a look at the side measurements. There was a theorem in geometry that said the smaller angle is opposite the smallest side. The larger angle is opposite the largest side. So which angle would technically be smaller then? The theta is your 60 and the unmarked one is your 30. That's what we needed to know. Our goal throughout this whole process was to find theta. So now we just did that. So we know that theta is 60 degrees. All right, how many radians is that? So I have this in degrees. How can I translate that to radians? Should I multiply by pi over 180 or 180 over pi? Yep, pi over 180 because we want those degrees to cancel out. Good, so let's go ahead and reduce that 60 over 180. I know the zeros cancel out for sure. That makes it easier to reduce then. So what is 6 over 18 reduced to? 3 on the bottom, right? 6 over 18 is the same as 1/3. Very good, 1 over 3. So in degree measures, it's 60 degrees. In radian measures, that translates to pi over 3. Awesome. Now when we get to the next lesson, the unit circle will do this for us. So we actually don't have to do this conversion process. It's going to do it for us. That's why I said the unit circle is going to be your best friend. All right, any questions with that one? You can do this without needing all the steps if you can remember that those are the side lengths for a 30, 60, 90 triangle. If you can realize that, you can do a lot of this mentally. But if you can't remember those facts, which is not uncommon for us at this part of the year to remember all those geometry facts, then the picture, we'd have to kind of go through this process with that picture. Now, my guess is you probably don't need to find this extra side length, but I did it just to prove the point that it does not fit the bill for a 45, 45, 90. All right, so you probably can cut out this whole process of finding the side length of 1 if you can identify the 30, 60, 90 part. You can with a calculator, but the process says to do it without a calculator. So if you did have a calculator, you could just punch that right in. And you can use inverses. Yes, that is correct. Technically, you could do sine inverse of this. And if you want to test that out, you'd have to probably switch. Maybe not. You can leave it in degree mode, I think. It should give you the 60. Go ahead and hit the second sign. So that's the one with the little -1 power then, right? So the inverses help you find the angle measurements, and this is what Isaias was referring to. So if I type in the square root of 3 over 2, notice how I put parentheses to end the 3 and then after the 2 as well. That's going to, oopsie, there we go. That's going to give you your 60. So you can do it very quickly with the calculator. Yay! And that's a plus, right? That not all geometry information was lost on us over the years. So that's good. You can use the inverse features to find the missing degree lengths, or measurements, I should say, because, yeah, okay. But it did say to do it without a calculator, so that's the thought process behind it all. Yeah. All right. Real quick, let's wrap it up here today. Let's find the missing variables in each triangle. So pick just one of them to do. Hopefully we all pick a different one so we can divide and conquer here. Show the work though with which trig function you're using to set it up. Are you using sine? Are you using cosine? Or are you using tangent? So kind of show the work behind it as well. So pick one of those to do on the board, and then I will glance over it to make sure it looks good, and then we'll wrap up for today. You guys are fast. All right, I see an error with one of the letters, and it's a minor error, but it did throw off the answer. Anybody find the minor error with one of the problems? Not the second one. Y actually looks good. So Y looks good. X is okay too. So that means it's got to be the first one. What's wrong with the setup of the first one? And again, it's just a minor error, but the minor error kind of threw off the rest of the answer. So looking at the 39, I do like that you're using cosine, but when you set up the fraction, we have adjacent over hypotenuse. We need to flip that, right? Yeah, so we need to actually take 23 over z. Yeah, sometimes your mind will play tricks with you on, at least mine does, with those setups, and just make sure you're double checking that. All right, so because we had that flipped, that threw off the process on how we should actually solve for z. So now to solve for z, we would first multiply both sides by z. And then divide by the cosine of 39. So do 23 divided by the cosine of 39 degrees. And what are we going to get for that outcome? $29.6. Okay. I'm going to move the answer. Okay, I saw it pop up over X, and I'm like, oh. Someone moved it. Yeah, 29.595. I was going to grab it and just throw it over here. Oh, that's okay, Tommy. I would have grabbed it and just thrown it over, but it's all good. All right, the rest of them look okay with their setup. So just double check the fractions as you're setting things up. Make sure that the numbers are in the correct location, and you should be good to go solving from there. All right, any questions with the trig we looked at today? All right, that's all I got for you. So I'll let you go so you can practice that and complete the 4.02 lesson. We will start that unit circle. I'll send some information about the unit circle sometime today so that you can have that printed off ahead of time if you have the capability to do so for Thursday's class. But we will start that venture with the unit circle in Thursday's class. So I will see everybody then. Bye, everyone.